Okay, now we're looking at limits of sequences. So if we were to say, like again, a lot of times sequences have very similar properties to functions. So if we took a sequence that had the nth term as a sub n equals 1 over 2n, that would be like 1/2, 1/4, 1/8, 1/16, and go on and on and on and on. We could say that as n increases without bound, it converges to 0. Because again, these denominators are getting larger. So as my denominator gets bigger, my overall number gets smaller. So in limit notation, we would say as n approaches infinity, 1 over 2n equals 0. And so we can kind of see that right here, where the limit as x approaches f of x equals L, and it's basically the exact same thing for a sequence as well. So as the sequence converges to a number, that becomes its limit. It is important to note that sometimes a sequence will diverge, which again means it might be alternating between positive and negative, and it's not approaching a unique number. So like we did in our previous, when we were using limits, we're going to do 3 examples of different limits and how they can have different answers. So or different sequences. So our first one is going to be 2n plus 1 over n plus 4. Our next one is going to be b sub n equals 2n plus 1 over n squared plus 4. So that's kind of the difference there. And then in this third example, we're going to have 2n squared on the top plus 1 over 4n squared on the bottom. Forgot c sub n. Okay, so I'm going to start on the left, a sub n. So I'm just going to start kind of listing out some of my sequences. And as I plug in a 1, I get 3/5. Then I get 5/6, 7/7, 9 over 8, 11 over 9, 13 over 10. And these are all basically going to equal, or they're going to the limit of 2. So as my numbers increase, again, they keep increasing, but they never go above 2. So I'm going to say the limit as n approaches infinity of 2n plus 1 and n plus 4 equals 2. Going to do the same process over here. Again, type in the first term, the 5th term, find the 10th term, find the 100th term. Find these terms that, again, tell you what your number is approaching. So I'm going to plug in a 1 and get 3/5. A 2, I get 5/8. A 3, I get 7/13. Okay, I see my numbers getting smaller. My number keeps getting smaller as I plug in the next numbers. I see that I am approaching the letter or the number 0. So I'm going to say that the limit of n approaching infinity, 2n plus 1 over n plus 4 equals 0. Lastly, again, I'm going to plug in different numbers. I'm going to say, all right, plug in a 1, I get 3/4. Plug in a 2, 9/16. Plug in a 3, 19/36. Plug in a 4, 33/64. You could plug in a 10, plug in 100. Try different numbers until you figure out what that number is getting close to. And in this case, this number is approaching 1/2. So the limit as n approaches infinity of 2n squared plus 1 over 4n squared equals 1/2. Last example. Finding the limit of a sequence. All right, so let's take the sequence whose nth term is a sub n equal to 8 over n to the third, n plus 1, 2n plus 1, all over 6. Begin by writing the nth term in standard rational function form as the ratio of two polynomials. So basically, what are we going to do? We are going to multiply. We're going to distribute this in here and this in here. So we're going to get 8, so equals 8 times n plus 1 times 2n plus 1 all over 6 times n to the third. And now I'm going to continue multiplying. I'm going to multiply as much as I can here. And I'm going to get let's see here, 16n to the third plus 24n squared plus 8n all over 6n to the third. And I notice that my coefficients all have a 2 in common. So what I'm going to do is I'm going to divide out a 2 from each of these. So I get 8n to the third plus 12n squared plus 4n all over 3n to the third. And so now again, this is where it can get, where you kind of have to analyze it and you have to think, all right, this has an n to the third. Here we have an n to the third, but this is only n squared and this is only n. So when you have the degree of the numerator, so degree of the numerator, which is 3, equals the degree of the denominator, which we have, again, 3 equals 3, then we can just compare our coefficients, and we know that that's going to be our answer because, again, it would be the same as when we divide by n to the third on each term. So if we tried to divide by n to the third on each term, again, n to the third over n to the third cancels out. And then all of this stuff, n squared over n to the third, when we get to this part, we say our limit as we're approaching infinity, our denominators are getting bigger. So this is going to equal 0 and this is going to equal 0. So it's like the same thing. Hey, n to the third over n to the third, this cancels out. So it's almost like a mini shortcut. If you see that your degrees are the same, you know that your limit, because of this property right here, is going to cancel out. And we're going to get the limit as n approaches infinity of 8n to the third plus 12n squared plus 4n all over 3n to the third equals 8 thirds.